Technology is the collection of techniques, skills, methods and processes used in the production of goods or services or in the accomplishment of objectives, such as scientific investigation. Technology can be the knowledge of techniques, processes, etc., or it can be embedded in machines, computers, devices and factories, which can be operated by individuals without detailed knowledge of the workings of such things. The human species' use of technology began with the conversion of natural resources into simple tools. The prehistoric discovery of how to control fire and the later Neolithic revolution increased the available sources of food, and the invention of the wheel helped humans to travel in and control their environment. Developments in historic times, including the printing press, the telephone, and the Internet, have lessened physical barriers to communication and allowed humans to interact freely on a global scale. The steady progress of military technology has brought weapons of ever-increasing destructive power, from clubs to nuclear weapons. Technology has many effects. It has helped develop more advanced economies and has allowed the rise of a leisure class. Many technological processes produce unwanted byproducts, known as pollution, and deplete natural resources, to the detriment of Earth's environment. Various implementations of technology influence the values of a society, and new technology often raises new ethical questions. Examples include the rise of the notion of efficiency in terms of human productivity, a term originally applied only to machines, and the challenge of traditional norms. Philosophical debates have arisen over the use of technology, with disagreements over whether technology improves the human condition or worsens it. Neo-Luddism, anarcho-primitivism, and similar reactionary movements criticize the pervasiveness of technology in the modern world, opining that it harms the environment and alienates people. Proponents of ideologies such as transhumanism and techno-progressivism view continued technological progress as beneficial to society and the human condition. Until recently, it was believed that the development of technology was restricted only to human beings, but 21st-century scientific studies indicate that other primates and certain dolphin communities have developed simple tools and passed their knowledge to other generations. Definition and usage. The use of the term technology has changed significantly over the last 200 years. Before the 20th century, the term was uncommon in English, and usually referred to the description or study of the useful arts. The term was often connected to technical education, as in the Massachusetts Institute of Technology. The term technology rose to prominence in the 20th century in connection with the Second Industrial Revolution. The term's meanings changed in the early 20th century when American social scientists, beginning with Thorstein Veblen, translated ideas from the German concept of Technik into technology. In German and other European languages, a distinction exists between technique and technology that is absent in English, which usually translates both terms as technology. By the 1930s, technology referred not only to the study of the industrial arts but to the industrial arts themselves. In 1937, the American sociologist Reed Bain wrote that technology includes all tools, machines, utensils, weapons, instruments, housing, clothing, communicating and transporting devices, and the skills by which we produce and use them. Bain's definition remains common among scholars today, especially social scientists. But equally prominent is the definition of technology as applied science, especially among scientists and engineers. Although most social scientists who study technology reject this definition, more recently, scholars have borrowed from European philosophers of technique to extend the meaning of technology to various forms of instrumental reason, as in Foucault's work on technologies of the self. Dictionaries and scholars have offered a variety of definitions. The Merriam-Webster Dictionary offers a definition of the term: the practical application of knowledge, especially in a particular area, and a capability given by the practical application of knowledge. Ursula Franklin, in her 1989 Real World of Technology lecture, gave another definition of the concept: it is practice. The way we do things around here. The term is often used to imply a specific field of technology, or to refer to high technology or just consumer electronics, rather than technology as a whole. Bernard Stiegler, in Techniques and Time, 1, defines technology in two ways: as the pursuit of life by means other than life, and as organized in organic matter. Technology can be most broadly defined as the entities, both material and immaterial, created by the application of mental and physical effort in order to achieve some value. In this usage, technology refers to tools and machines that may be used to solve real-world problems. It is a far-reaching term that may include simple tools, such as a crowbar or wooden spoon, or more complex machines, such as a space station or particle accelerator. Tools and machines need not be material. Virtual technology, such as computer software and business methods, fall under this definition of technology. Brian Arthur defines technology in a similarly broad way as a means to fulfill a human purpose. The word technology can also be used to refer to a collection of techniques. In this context, it is the current state of humanity's knowledge of how to combine resources to produce desired products, to solve problems, fulfill needs, or satisfy wants. It includes technical methods, skills, processes, techniques, tools and raw materials. When combined with another term, such as medical technology or space technology, it refers to the state of the respective field's knowledge and tools. State-of-the-art technology refers to the high technology available to humanity in any field. Technology can be viewed as an activity that forms or changes culture. Additionally, technology is the application of math, science, and the arts for the benefit of life as it is known. A modern example is the rise of communication technology, which has lessened barriers to human interaction and, as a result, has helped spawn new subcultures. The rise of cyberculture has, at its basis, the development of the Internet and the computer. Not all technology enhances culture in a creative way. Technology can also help facilitate political oppression and war via tools such as guns. As a cultural activity, technology predates both science and engineering, each of which formalize some aspects of technological endeavor. Science, engineering and technology. The distinction between science, engineering and technology is not always clear. Science is the reasoned investigation or study of natural phenomena, aimed at discovering enduring principles among elements of the phenomenal world by employing formal techniques such as the scientific method. Technologies are not usually exclusively products of science, because they have to satisfy requirements such as utility, usability and safety. Engineering is the goal-oriented process of designing and making tools and systems to exploit natural phenomena for practical human means, often using results and techniques from science. The development of technology may draw upon many fields of knowledge, including scientific, engineering, mathematical, linguistic, and historical knowledge, to achieve some practical result. Technology is often a consequence of science and engineering, although technology as a human activity precedes the two fields. For example, science might study the flow of electrons in electrical conductors by using already existing tools and knowledge. This newfound knowledge may then be used by engineers to create new tools and machines, such as semiconductors, computers, and other forms of advanced technology. In this sense, scientists and engineers may both be considered technologists. The three fields are often considered as one for the purposes of research and reference. The exact relations between science and technology in particular have been debated by scientists, historians, and policymakers in the late 20th century, in part because the debate can inform the funding of basic and applied science. In the immediate wake of World War II, for example, in the United States it was widely considered that technology was simply applied science, and that to fund basic science was to reap technological results in due time. An articulation of this philosophy could be found explicitly in Vannevar Bush's treatise on post-war science policy, Science, the Endless Frontier. New products, new industries, and more jobs require continuous additions to knowledge of the laws of nature. This essential new knowledge can be obtained only through basic scientific research. In the late 1960s, however, this view came under direct attack, leading towards initiatives to fund science for specific tasks. The issue remains contentious, though most analysts resist the model that technology simply is a result of scientific research. History. Paleolithic. The use of tools by early humans was partly a process of discovery and of evolution. Early humans evolved from a species of foraging hominids which were already bipedal, with a brain mass approximately one-third of modern humans. Tool use remained relatively unchanged for most of early human history. Approximately 50,000 years ago, the use of tools and complex set of behaviors emerged, believed by many archaeologists to be connected to the emergence of fully modern language. Stone tools. Hominids started using primitive stone tools millions of years ago. The earliest stone tools were little more than a fractured rock, but approximately 40,000 years ago, pressure flaking provided a way to make much finer work. Fire. The discovery and utilization of fire, a simple energy source with many profound uses, was a turning point in the technological evolution of humankind. The exact date of its discovery is not known. Evidence of burnt animal bones at the cradle of humankind suggests that the domestication of fire occurred before 1 million BC. Scholarly consensus indicates that Homo erectus had controlled fire by between 500,000 BC and 400,000 BC. Fire, fueled with wood and charcoal, allowed early humans to cook their food to increase its digestibility, improving its nutrient value and broadening the number of foods that could be eaten. Clothing and shelter. Other technological advances made during the Paleolithic era were clothing and shelter. The adoption of both technologies cannot be dated exactly, but they were a key to humanity's progress. As the Paleolithic era progressed, dwellings became more sophisticated and more elaborate. As early as 380,000 BC, humans were constructing temporary wood huts. Clothing, adapted from the fur and hides of hunted animals, helped humanity expand into colder regions. Humans began to migrate out of Africa by 200,000 BC and into other continents, such as Eurasia. Neolithic. Through classical antiquity, man's technological ascent began in earnest in what is known as the Neolithic period. The invention of polished stone axes was a major advance that allowed forest clearance on a large scale to create farms. Agriculture fed larger populations, and the transition to sedentism allowed simultaneously raising more children, as infants no longer needed to be carried, as nomadic ones must. Additionally, children could contribute labor to the raising of crops more readily than they could to the hunter-gatherer economy. With this increase in population and availability of labor came an increase in labor specialization. What triggered the progression from early Neolithic villages to the first cities, such as Uruk, and the first civilizations, such as Sumer, is not specifically known. However, the emergence of increasingly hierarchical social structures and specialized labor, of trade and war amongst adjacent cultures, and the need for collective action to overcome environmental challenges such as irrigation, are all thought to have played a role. Metal tools. Continuing improvements led to the furnace and bellows and provided the ability to smelt and forge native metals. Gold, copper, silver, and lead were such early metals. The advantages of copper tools over stone, bone, and wooden tools were quickly apparent to early humans, and native copper was probably used from near the beginning of Neolithic times. Native copper does not naturally occur in large amounts, but copper ores are quite common, and some of them produce metal easily when burned in wood or charcoal fires. Eventually, the working of metals led to the discovery of alloys such as bronze and brass. The first uses of iron alloys such as steel dates to around 1400 BC. Energy and transport. Meanwhile, humans were learning to harness other forms of energy. The earliest known use of wind power is the sailboat. The earliest record of a ship under sail is shown on an Egyptian pot dating back to 3200 BC. From prehistoric times, Egyptians probably used the power of the annual flooding of the Nile to irrigate their lands, gradually learning to regulate much of it through purposely built irrigation channels and catch basins. Similarly, the early peoples of Mesopotamia, the Sumerians, learned to use the Tigris and Euphrates rivers for much the same purposes. But more extensive use of wind and water power required another invention. According to archaeologists, the wheel was invented around 4000 BC, probably independently and nearly simultaneously in Mesopotamia, the northern Caucasus and Central Europe. Estimates on when this may have occurred range from 5500 to 3000 BC, with most experts putting it closer to 4000 BC. The oldest artifacts with drawings that depict wheeled carts date from about 3000 BC. However, the wheel may have been in use for millennia before these drawings were made. There is also evidence from the same period for the use of the potter's wheel. More recently, the oldest known wooden wheel in the world was found in the Ljubljana marshes of Slovenia. The invention of the wheel revolutionized trade and war. It did not take long to discover that wheeled wagons could be used to carry heavy loads. Fast potter's wheels enabled early mass production of pottery. But it was the use of the wheel as a transformer of energy that revolutionized the application of non-human power sources. Medieval and modern history innovations continued through the Middle Ages with innovations such as silk, the horse collar and horseshoes in the first few hundred years after the fall of the Roman Empire. Medieval technology saw the use of simple machines being combined to form more complicated tools, such as the wheelbarrow, windmills and clocks. The Renaissance brought forth many of these innovations, including the printing press, and technology became increasingly associated with science, beginning a cycle of mutual advancement. The advancements in technology in this era allowed a more steady supply of food, followed by the wider availability of consumer goods. Starting in the United Kingdom in the 18th century, the Industrial Revolution was a period of great technological discovery, particularly in the areas of agriculture, manufacturing, mining, metallurgy and transport, driven by the discovery of steam power. Technology later took another step with the harnessing of electricity to create such innovations as the electric motor, light bulb and countless others. Scientific advancement and the discovery of new concepts later allowed for powered flight, and advancements in medicine, chemistry, physics and engineering. The rise in technology has led to the construction of skyscrapers and large cities whose inhabitants rely on automobiles or other powered transit for transportation. Communication was also greatly improved with the invention of the telegraph, telephone, radio and television. The late 19th and early 20th centuries saw a revolution in transportation with the invention of the steam-powered ship, train, airplane, and automobile. The 20th century brought a host of innovations. In physics, the discovery of nuclear fission has led to both nuclear weapons and nuclear power. Computers were also invented and later miniaturized utilizing transistors and integrated circuits. The technology behind got called information technology, and these advancements subsequently led to the creation of the Internet, which ushered in the current information age. Humans have also been able to explore space with satellites and unmanned missions going all the way to the Moon. In medicine, this era brought innovations such as open-heart surgery and later stem cell therapy along with new medications and treatments. Complex manufacturing and construction techniques and organizations are needed to construct and maintain these new technologies, and entire industries have arisen to support and develop succeeding generations of increasingly more complex tools. Modern technology increasingly relies on training and education. The designers, builders, maintainers, and users often require sophisticated general and specific training. Moreover, these technologies have become so complex that entire fields have been created to support them, including engineering, medicine, and computer science, and other fields have been made more complex, such as construction, transportation and architecture.